Hello everyone. We've been learning about congruency of triangles and similarity of triangles in our past few videos. In this video, let us consider this equilateral triangle or triangle with all of its sides equal, and in this case each side is equal to 2a. The measure of each side is 2a. So ABC is an equilateral triangle with sides equal to 2a, and we are going to find the measure of the altitudes of this triangle. How many altitudes does it have? Any triangle would have 3 altitudes, and we are going to find the measure of the altitudes of this triangle. So let's first consider the first one with BC as the base. So if BC is the base, we drop a perpendicular from A, and this is the height of the triangle ABC. So it's 90 degrees here. It makes an angle 90 degrees with BC. Let us mark this point as D. So let's draw one more altitude considering AC as the base of the triangle. So let's drop a perpendicular from B to AC. So this is the perpendicular. It makes an angle 90 degrees at E. So let's say that B is one more altitude. So now we have two altitudes in the figure. One is AD which is perpendicular to BC, and we have BE, another height of the triangle with AC as the base. So BE is perpendicular to AC. Now just let's see if there is any relationship between these two altitudes. Now, in order to look for a relationship, let us consider the two triangles. One is ADC. Let's consider triangle ADC. AD is one of its sides, right? Which is what we require. And we'll also consider the triangle BEC. BE is one of its sides. BEC. So what is how does it how can we compare? We see that both the triangles are right angled, the one at D, the other one at E, right? ADC is right angled at D and BEC is right angled at E, and the angle at C is common to both. This angle, or here in the picture it is C is common to both the triangles. So two angles are equal. Two corresponding angles are equal in these two triangles. So I can claim that the two triangles are similar. They are similar to one another. And also we find that the two sides, one is BC, here it is BC, and in this triangle it is AC. So these two are sides of triangle ABC, and they are equal to one another because we are talking about an equilateral triangle. So AC is equal to BC. Or what we see is, in these two triangles which we are talking about, the similar triangles, we see that one of its sides, corresponding sides, are equal. That is, the scaling factor which we are talking about is equal to 1. Or the triangles are congruent, right? The triangles are not only similar, they are congruent to one another. So triangle ADC is congruent to triangle BEC. So if they are congruent, it means that AD is equal to BE. The length of AD is equal to length of BE as they are corresponding sides. So what have we concluded here? We have concluded that the altitudes are same. That is, the measure of the altitudes are same, whatever be the base. And the same is going to happen if we have an altitude drawn from C to the third base. I mean to base AB. Right? So we can say that the altitudes of the triangle, of this triangle ABC, all the three altitudes are equal. Right? So if we have an equilateral triangle, this is my conclusion. If a triangle ABC has all sides equal, all three sides equal, then the altitudes also are equal. So what I have tried to do here is, I have tried to find the answer of this question easier. That is, we have been asked to find each of its altitudes. Now it's enough if you find one, because we know that all of them are equal. right? So let's proceed to finding the altitudes. For that, I think I'll have to make a fresh picture because we have drawn many lines in this picture. So this is an equilateral triangle once again, and this is ABC, and it's given that the sides measure 2a each. Each side, all sides are equal, being an equilateral triangle, and all of the sides equal to 2a. Now the question is, find the altitude of this triangle. So let me draw one altitude, AD, which is perpendicular to BC, and let me try to find the length of AD. So now let's compare these two triangles. Done here. Let's compare triangle ADC and triangle ADB. Why are we comparing? Because even looking at the figure, because the sides are equal, looking at the figure, we have an intuition that maybe the perpendicular bisects BC. It divides BC equally. So we're just trying to verify it. We need a proper proof. Intuition doesn't work here. We need a proper proof. So let us compare ADC and ADB. Already A is common to both the no, actually A is not common. A has been divided. I can't say A is common, but yeah, B and C are equal. So angle C here and angle B here, both of them are equal to 60 degrees. In an equilateral triangle, all angles are equal and they are equal to 60 degrees. So you already have angle C is equal to angle B. What else do we have? We have another angle, which is angle at D, or I can say angle ADB is equal to angle ADC, right? Both are equal to 90 degrees. This one is equal to 60 and these two are equal to 90 degrees, and this is enough. I don't have to work more because I have two angles equal and the third angle is automatically going to be equal. So these two triangles are similar. But are they congruent also? Yeah, they are, because AD is common to both the triangles. The side AD is common to both the triangles. So I can conclude by AAS congruency. It can be SAA or ASA or whatever. All are same because all the three angles are equal. So by this postulate of congruency, let's conclude that these two triangles are congruent. But what we need is these two sides, BD and DC. They are equal, right? BD from this triangle and CD from this triangle. BD is equal to CD. So this is what we were looking for, isn't it? So we can now say that BD is equal to A and DC is equal to A. Both of them are equal to A. AD bisects BC. It divides BC into two equal halves. So each one of it is equal to A. Now it's easier for us to find the length of AD using the Pythagoras theorem, because we have a right angle here. So we can use the Pythagoras theorem. What does it say? The Pythagoras theorem says that in any right angle triangle, it's applicable to right angle triangles, the sum of the squares of two sides, the two arms of the right angle triangle, that is in this case AD squared plus CD squared, will be equal to the hypotenuse, which is AC squared, right? So I do not know what is AD squared, that's what we'll have to find. So AD squared will be equal to AC squared minus CD squared, and we know both the lengths. We know what is AC, it's 2A the whole squared. AC is 2A the whole squared minus CD is, we found just now that it is equal to A. So 2A the whole squared minus A squared is the square of the length which we are looking for. So let's find it out. AD squared is equal to this is 4A square minus A square, or 3A square, but we do not require the square, we need the root of AD square, that is we need the length of AD. So what is the length of AD? Just take square roots on both sides. Length of AD would be equal to root 3A, right? So we have ultimately found the altitude of an equilateral triangle. It is root 3A, and we have already found that all altitudes, all the three altitudes are equal. So whatever be the altitude, every length, all these lengths, whether it is this BE or this, the one in black or the one in blue AD, all of them would be equal to root 3a, right? I hope you understood. Thank you.